Okay, we're coming to our final presenter of the evening. Tonight, the final presenter is Nick Bond. Nick is a principal research scientist with the Cooperative Institute for Climate, Ocean, and Ecosystem Studies at the University of Washington. He's a climatologist for the state of Washington, and he joins NSAW tonight to give an outlook for the winter 2020-2021 season. His presentation is going to review prospects for the winter ahead and is going to address those burning questions related to La Nina, the copious or not copious amounts of snow we can expect in our Pacific Northwest mountains. Nick will feature the latest results of climate models to address these important questions. And thank you so much for being with us tonight, Nick. Go ahead.
Yeah, thank you. I'm going to share my screen and hope for the best, right? You should be seeing what, well, I've been your state climatologist for a little over 10 years here in Washington State. This isn't my staff photo yet, but maybe it's kind of dangerously close to it. What I'm going to talk about today, of course, is the outlook for the winter ahead. I'm going to first review last year's weather, talk just a little bit of flavors of La Nina. Renee mentioned that. You know what La Nina is? It's Spanish for the Nina. Anyway, just to help you out there. And then, of course, some forecasts of mean temperature and precipitation. All right. The winter last year, what I am showing here is for the period of November through March, the temperature anomaly distribution on the left and the precipitation in terms of percentile on the right, where the red colors being warmer than normal, and there are a few blues showing cooler than normal. And the yellows and browns on the right and the precipitation show where it was on the dry side, and the greens where it was wetter than normal. And the screaming message was, except for, you know, some isolated spots in the Northwest, it was on the warm side as forecast. And so not a pretty good forecast in terms of temperature. And it was especially warm on the kind of east slopes of the Cascades of Washington State and into northern Idaho. It was dry through much of the region, with the exception of the western slopes of the Cascades, especially in the northern part of Washington, and dry through much of Oregon. All right. How did this come about? One of the things that I do every day, almost, well, I have coffee first, but it's pretty early in the game. I check out the weather patterns and that sort of thing. And what is shown here is for that period of November through March of last year, of about 20,000 feet up in the atmosphere, what the geopotential height, same thing as pressure pattern was compared to normal. And that big red south of Alaska is where there were higher heights, higher pressure than normal. Higher heights aloft tend to be associated with warmer air temperatures. And then the kind of circulation around the highs and lows, with the clockwise around the high and counterclockwise around the lows, kind of where that air is coming from. And so what this kind of pattern resulted in, it was a decent amount of moisture coming into Washington State. Oregon was kind of ripped off some, and kind of near normal temperatures again for the west side, and actually, like I showed before, warm temperatures for east of the Cascades. And those warm temperatures there were because of basically a lack of any real cold air outbreaks. What's kind of interesting, I think, is burn this pattern into your retina here and compare that with the two previous winters of 17, 18 in the upper left and 18, 19 in the low right. And in each, so 3 years in a row there, at least south of Alaska, southwest of Alaska, I have higher heights than normal in the kind of pattern. And so that's kind of a remarkable run there of, to be sure, not identical patterns, but something pretty similar on the large scale. Let's drill down a little bit into more what happened in the tangible weather. And from a kind of weather weenie point of view, like myself, it was kind of a bland year. We did have some floods in December in Western Washington, but otherwise, in terms of drama, not a great deal. But you know, maybe that's okay. Another perspective I'd like to show with these pair of graphs, and this is for Stehekin up in the upper, just above the upper end of Lake Chelan. And what is shown at the top, that green line, is the accumulated precipitation from November 1st through the end of March last year, compared to the brown line, which is the normal accumulation of the precipitation. The lower graph shows the blue bars where the temperatures in the range each day, with the brown stripe in the middle, kind of the normal, and the reds and the blues on top and below that, showing the records. And what we can see is what a disaster the early part of last winter was, with a very dry. October was cold, but November and December was terrible in terms of the amount of precipitation. It wasn't especially warm, but especially when you look at kind of snow depths, and here use White Pass just for illustration, it was really meager snowpacks there early in the season there, especially during that key time for the ski resorts, you know, just 10, 15 inches of snow there at the end of the calendar year. But then January happened, and the first couple of weeks of January, just huge increase in the snowpack, more than 50 inches there at White Pass, also Stevens Pass. This was generally the what happened through, well, northern Oregon through the Washington Cascades. Here it showed it kind of tapering off after that at White Pass. It continued to build some at Stevens Pass, and at least at higher elevations, ended up being a pretty good year. All right, about forecasts. We, I think I had trotted out this slide before about, you know, some of the things that go into that. I'm going to be showing some model results and so forth, but you know, the important points to take away here is that on seasonal timescales, we do quite a bit better forecasting temperature than precipitation, have a lot more skill there. And that all we can do is talk about kind of general terms. Is there higher odds of it being above normal temperatures or below normal temperatures, or is it just you know, kind of a complete toss-up? One of the things that I keep track of very closely, part of some of my research, is what's happening in the North Pacific Ocean. And there, this is something that's a little disquieting, is that the water is, and this is sea surface temperature anomalies from a couple of weeks ago, is warmer than normal. And the magnitude here is something like a degree C, 1.5 degrees C, which is a pretty sizable anomaly. And I've done some really simple sort of statistics, this scatter plot just showing, based on what the temperatures are off our coast in October, what's that mean for the winter temperatures to follow? And yeah, sure, it's a shotgun blast here, but there is a tendency for when the water's cold out there, we almost never have a really warm year. And on this scatter plot, the vertical axis is the temperatures, the horizontal axis is the sea surface temperature. And then when there's warm water out there, we rarely have a really cold year. The place that I did this comparison for was the central basin of Washington State, because this is the air that is kind of drawn into the passes, especially Snoqualmie Pass, and is a real key. The colder we have that central basin air, the more we can keep the snow around, especially at lower elevations in near the Cascade passes. All right, but let's go on more to the forecast here, and as usual, kind of talk about, you know, what's happening in terms of El Nino and La Nina. it makes me think in these kind of talks, it should almost include a drinking game. Every time I say El Nino or La Nina, everybody has to chug or something like that. But anyway, what we're expecting is a very high odds, approaching 100% of having La Nina conditions in the at least into winter and extending into next year. That's shown by those bar graphs there in the upper left. The individual models that we use to forecast La Nina are shown in the plot at the lower right. And what is kind of interesting is just in the last couple of months, we've gotten much more sure of this, and it's much more emphatic that this is going to be at least a moderate and perhaps even a strong event. Now, yeah, again, you know, we sometimes use these various cartoons to kind of illustrate things, and this is all kind of silly, but maybe not, right? You know, have something going there. I didn't come up with that cartoon, but anyway. Back to the La Nina, there are different flavors of La Nina, and in particular, there are ones in which the clusters of thunderstorms that their movement and strength and persistence and so forth in the tropical Pacific, where they are really impacted, and others in which the water might be on the cool side there, but we just don't see that response in the kind of tropical atmosphere. And so far, so good. This is one of those, what's called an OLR La Nina, in which we expect the kind of response we've seen in previous La Ninas, which produces a kind of weather patterns that bring us decent amounts of precipitation, and especially after the first year, colder than normal temperatures. Kind of consistent with that idea is what the models are showing and how the trend in the model results. What I'm showing here in these two sets of plots are the temperature anomaly forecasts from a group of US climate models. And in the lower right are those model simulations from September for December through February. In the upper left are, in better focus, are the distributions from the models run in October. And with time, the models are making it colder and colder in terms of Pacific Northwest. They're also showing it kind of wetter and wetter. And in that regard, what I'm showing here is just the individual model results themselves for precipitation, again, focusing on the December through February period, and just the remarkable consistency from model to model. There's 7 of them here. In the lower right is actually the European models as a group shown, and just how similar they are in their patterns of where they expect that period to be wetter than normal versus drier than normal, with the greens and blues being wetter than normal. And I've never seen such consistency among the models. Doesn't mean right, but it does give us a little more confidence that we're going to have a decent amount of precipitation at least this year. All right. Here's a kind of a different collection of models, but just getting back to the kind of overall flow patterns, it looks like one of those situations, which is typical with La Nina, and which we've kind of had the last 3 winters, where there's more flow out of the Northwest than usual. That means more weather disturbances out of the Gulf of Alaska rather than coming straight out of the West. And so a little bit on the cool side, plenty of moisture. This is pretty good news for us, terrible news for California and the Southern Tier states. And you'll see why here in a minute. And so again, quite a bit of consistency from the models in terms of the pressure patterns they are forecasting. All right, so the actual forecast, made you wait some for this. This is out of the Climate Prediction Center in NOAA. These are the people that are, paid to make these forecasts, and they're showing at least the kind of next 3 months, November through January. The temperature map on the left shows increased odds relative to usual of cooler than normal temperatures in just the northwest part of Washington state. And then when you look to January and March, the last part of winter, greater odds of cooler than normal temperatures and extending across the northern tier of the states. And this is a kind of a classic La Nina temperature pattern. The models themselves aren't showing it cold in North Dakota, and so they're going with, hey, this is a strong La Nina, and this is what has happened before. And in terms of precipitation, they're showing it wet, above odds of it being wetter than normal, both in the next 3 months and the latter part of winter. If anything, and this is kind of a tentative signal, La Ninas tend to be wetter early before the first of the calendar year and colder late after the first of the calendar year. But the models are so emphatic about it being wet, even in late winter, that that's reflected in the forecast as you're seeing in the lower right. All right, just I want to take just a couple of minutes, a minute, showing something about, it's kind of a gleam in the eye, but something about a phenomenon called the MaddenJulian Oscillation, and some work that is being done, has been going on for a while, but is increasing, about trying to bridge the gap between the short-term weather forecasts and these really general seasonal weather forecasts that are on timescales of months to or more. And in particular, in the same way that El Niños and La Niñas disrupt global weather patterns, winds and pressure, there's this phenomenon called the MaddenJulian Oscillation, featuring big clusters of thunderstorms that is cyclic on very roughly 30 to 60 day timescales, that seems to have a connection with pressure patterns and weather in other parts of the globe. And so essentially that what happens is these big clusters of thunderstorms slowly move eastward from the Indian Ocean across the West Pacific. And when they do, they kind of just disrupt the global circulation. And what's important from our point of view is that during different phases of this cycle, there's seems to be systematic impacts on the precipitation in the Pacific Northwest. And in particular, when the blues here, looking at the maps on the left, show where the thunderstorm, these clusters are active. When they're active over the Indian Ocean and it's suppressed over Indonesia, we tend to be dry, at least early in the winter season. And then as that system moves over Indonesia, then we get wet. And so we can actually kind of anticipate these sorts of this sort of thing at least 2, maybe 4 weeks out. And so we have some prospects of getting a little bit of information there, again, between this kind of the weather scale out to a week and the seasonal time scales out months or more. All right, just one more kind of slide. I'm focusing on snow for this crowd, of course, but there are other elements of the weather that matter around here. Floods. We tend to have increased frequency of flooding, especially watersheds with northwest facing slopes in La Nina years. Windstorms, it's kind of a real noisy signal. We tend to have at least more of the nuisance kind of windstorms with scattered power outages, not necessarily the real big whoppers, but we've had some of those during La Nina. Cold air outbreaks, we tend to have a few more of those during La Nina winters. It's been a long, long time since we've had the extremely low temperatures with those. So, we're fighting climate change there. And then finally, I'm just going to jump down to the bottom. Into season snowpack. We may have to wait a while like last year because the really cold temperatures with La Nina tend to kick in after the first of the year. But I think we're going to have a decent snow year, and especially one of the more robust relationships between El Nino and La Nina and something related to the climate is the end of season snowpack. And so we're looking for a decent snowpack, not just for winter sports, but for water supplies, hydropower, freshwater ecosystems, everything. And so with that, I just appreciate your attention, the chance to get to talk to you again, and hopefully next week, as long as, or next year, as long as that photo that I had at the start isn't the reality. I look forward to talking with all of you in person. So thank you.
Hey, Nick, thank you so much for that presentation. I think obviously this crowd is one where those questions are top of mind in this changing of seasons. So the clarity was really fantastic. We've had a handful of questions come in from the audience because it's not every day you get to chat with your state climatologist. So Gregory is wanting you to get a little smaller scale.
Okay.
If we're having favoritism for northwest flow, do we expect a southern shift of the Puget Sound convergence zone, which would favor southern Cascades / Rainier over central Cascades surrounding Highway 2?
Yeah, that's why it's so tough talking to you guys. You know too much. He's exactly right that the kind of orientation of the flow there, basically when it's more westerly flow, then it'd be Stevens Pass or something that would be the beneficiary of the convergence zone. And when it's more out of the north, then yeah, it's more Snoqualmie or sometimes even a little bit further south. And that happens, we see that routinely, of course, with on the event, over the course of an event, that the convergence zone will start in the north and move south. But this could be one of those in which, yeah, maybe the Central Cascades does, in general, pretty well.
That's great. Thanks, Nick. Eric Olson is wondering, with the possible link between MJOs and PNW precipitation, is there a way for the public to track the MaddenJulian Oscillation? That was also a question I had. So
yeah, that's right. There is, yeah, you follow your nose. There's, if you Google MaddenJulian Oscillation, there's some resources there. There's actually some, and I meant to mention this, so I'm glad I have a chance here, is an experimental forecast on those kind of 3 to 4 week timescales that are really, a lot of they're predicated on what the MJO is doing. And you can track me down and I can give you, the actual links in that, but sub-X forecasts. If you Google sub-X, all one word, SUBX forecast, you can see there's a website in which you can kind of explore for yourself, the kind of extended outlooks that in part are kind of driven by the MJO.
Thanks. Really appreciate that resource. It's really great to bring a way the public can get involved in these questions, in this work. Doug is asking, well, he thanks you for the insights and is wondering whether the presence of La Nina influences, amplifies, or mutes the shorter intraseasonal variations that can impact PNW precip and temperature.
Yeah.
From your view, sorry, how important are other oscillations, or as they affect our tangible weather through the season? That's
yeah. And so in some ways, when there's La Ninas and especially El Ninos, that kind of mutes the impact of the MJO, especially El Ninos. I've done some work, it hadn't been published or vetted or anything, that has shown that actually the MJO during La Nina years kind of is related to our cold air outbreaks. Not so much, not necessarily just precipitation, but when we get the really cold air out of Canada. And so, but there's not a clean separation there. And I want to emphasize the MJO doesn't absolutely determine what's going to be going on those kind of timescales, but it just kind of loads the dice one way or another. But still, if we have just that edge, why not use it?
Thanks. That was a fantastic answer. We have a question from an NWAC staff person, Dennis, who is wondering if there is a tool where one can look at historical snow depths from around the Northwest during different NSAW phases.
Yeah, well, that's Dennis, to his credit. Yeah, we're working on that. The State Climate Office does host a website with a bunch of the information that we're trying to put together a much more user-friendly and complete tool for that purpose. And just in the interest of time, if we're kind of more interested in that, please feel free to contact the office. We're there for you. If you make a legitimate request, we'll do what we can to, kind of help you out and show you what's available now. And hopefully relatively soon we'll have a Tableau based interface that'll be really slick to use for that purpose.
Very cool. Thank you for that insider knowledge. And I'm sure we will publicize that information when it's out there. And Nick, thank you so much. I think in the interest of keeping on schedule for the last evening of NSAW, we will wrap up, but thank you so much. That does conclude our final night of NSAW 2020, and huge thank you to the amazing speakers from this evening, as well as all the previous NSAW sessions. I know that everyone here at the NWAC team hopes that these 4 sessions have helped our viewers get teed up for a really informed as well as exciting winter season. NWAC relies heavily on the wonderful community members ranging from our membership program, submitting public observations, to volunteering with programs like our Trailhead Outreach program. The goal of Trailhead Outreach is related to setting up a tent at popular trailheads to chat with recreationalists and inform them about forecasting services and educational opportunities related to the center. With the boom we expect in the backcountry this season, THO is more important than ever. So if you're interested in volunteering, we are holding trainings in the coming weeks that will go more in depth on how we are adapting to COVID-19 reality and updates for this season. So that form is in the chat. And with that, I will pass it back to Scott for some final concluding remarks.
Awesome. Thanks, Renee. And thanks so much to all who presented tonight and to all who presented in the prior 3 nights. And also just a thanks to you all for taking the time to join us and learning about the backcountry, keeping your mind sharp, and continuing the process of lifelong learning around the backcountry. So yeah, tonight's the final night of NSAW. And we'll be sending out the recordings for all 4 sessions tomorrow morning. So pay attention to your email. You'll get a link. If you have any issues with that, just feel free to reach out to us. And then just a reminder that the raffle for NSAW will close in under an hour. We'll be closing that tonight at 8 p.m. And as Renee mentioned, and as we've mentioned a few times, that NWAC's a community-supported organization. One of the best ways to help support NWAC is through your membership. And if you're not yet a member, consider joining today. And that's about it. Have a great night. have a wonderful winter. Feel free to reach out, and we will talk to you all soon. Good night.